Welcome, everyone. Welcome to the first session of this morning after the keynote. This morning we are going to talk about Flyway, database migrations made easy. So we'll have a bit of a look at what that means. A few words about myself. My name is Axel. I've been in the industry for a while now, actually since the end of the 90s, and during this time, I did lots of consultancy for many different industries, many different projects, and over the years, I always found that the intersection between development and operations was a place where there was a lot of efficiency potential to be gained, and so that's an area where I've naturally gravitated towards, and so that brought me also into the space of continuous delivery, which is a topic I've been actively speaking about on many conferences for the last 5 years, and doing some trainings in that area as well these days. And about 5 years ago as well, in April 2010, to be correct, I had a look at the problem of I had some project and I needed to basically evolve it over time, changing the structure of the database, and I was looking for some tools out there and just couldn't find a tool that was easy and fit the job and my idea of what a good solution would be there. So that's how Flyway was born. I naively thought an open source project would be awesome, and now I see how all my weekends and nights are evaporating. But it's all good. It's good fun. So that's one of the things I do. But my main job these days is actually this. It's Boxfuse. It's a company I founded just last year, but we've been working on it for a bit longer. It's basically a way to go from an application to a hardened system image, so a very minimal image in a couple of seconds. So you feed it an application, a jar file, a WAR file, and you get a hardened system image that's about 1% of the size of a regular image these days. So we get rid of the operating system, we get rid of provisioning. It's all just being transformed immediately on the fly, and then you can run it on your machine on VirtualBox for testing, or on AWS with zero downtime, blue-green upgrades and all that out of the box. So if that's an area that interests you, I'd like to invite you to check it out as well. So we've got 50 minutes today. It's not a very long slot, and we actually have a fair number of things I'd like to cover. So if you don't mind, I would like to ask you, if you have any questions, to hold on to them till the end. I'll be around after the session as well. I think we'll probably have a few minutes at the end to do a Q&A, but if we kind of run over time, people that want to move to the next session won't have any problems with that, and I'll stick around if there are more questions, no problem. So let's get to know each other. Who is using a relational database today? Pretty much everyone. Perfect. You're in the right place. So I think the relational database is, I wouldn't quite say gone out of fashion, but it's been facing a lot of hype from competing technologies that fall into the broad NoSQL denomination. And so I actually have to confess I really like relational databases. Because they bring a lot of very valuable things to the table, which I really don't want to give up that quickly. I think the first one is of course having proper transactions and just knowing that the stuff's actually there and will not just maybe eventually get there. I think that's a very powerful thing to have. And of course we're talking here about systems that have been around for a long time, and of course. Age is not always a good thing, but in this case here, it also means it's been battle tested. It's very reliable, and we've got very good performance out of these systems. Every release is still improving, especially if you look at databases like Postgres, where there is a lot of progress still happening and a lot of very interesting things there. But it's still very fast performance on a single node. And so if we talk about single nodes, I think the last few years we've really had a very interesting dynamic happening in the market as well, where it's now really possible to scale up really high and still work with a single node, and the simple deployment topology that goes with it, that really enables scaling up a long, long way. And of course, the nice thing about the way the data is structured as well in a relational database is that you can defer decisions on how to query it. You don't need to know at the time you're creating the data, at the time you're creating the structures, you don't need to know at that time how you're going to query it. You can do it later, which is a luxury you don't have with a lot of other solutions. So I strongly believe these days that relational databases should be your default choice. When you start, and only when you do reach their limits, do branch out to more specialized solutions. So we briefly touched upon scaling, but one thing I read a while ago, and I thought it was just superb. It's a bit exaggerated, but I thought this was just a great quote. It's from a guy named Clay Shirky. Algorithms are for people who don't know how to buy RAM. And these days, RAM is really cheap. You can get machines with 0.5 terabyte of RAM for just a few thousand, and you can order machines with 6 terabytes of RAM from Dell, and you can go really a long, long way with a very simple topology that doesn't have a network in between to kind of make things unreliable, where you need to kind of deal with all that. So it's actually very nice. And so RAM these days is also something that of course is very fast. So you can start to keep a lot of things in RAM and just only touch disk when you actually need to write something, and all your reads can be performed out of RAM. So I think this is really a big thing there. The other thing, of course, to kind of stretch your runway as far as scaling up is concerned is just to stick to a couple of simple rules. And I think just leaving your blobs and your general large objects out of your database and just putting them in object storage somewhere and just keeping a reference in a database will take you a long, long way to extend the life of what's possible on a single machine. And even then, when you do reach the limits of single machines, you do have the option to look at your data, how it can be partitioned, along which lines, and then you have techniques like sharding to basically replicate the infrastructure along those lines. But there's actually a couple of people using relational databases at really high scale. A couple of years ago, I had the pleasure to meet one of the architects at King. They're this Swedish company that make this horrible little iPhone and iPad game, Candy Crush Saga, and they had basically this huge problem that they're being permanently DDoSed by their own user base. They've got over 1 billion sessions every day being played, where you need to keep track of the score and the progress on the levels, and it's all kind of coming in all the time, and somehow they need to be able to survive that influx of data. And so they had to look at many different types of architectures and possibilities they could put in place, because you need some serious expertise to be able to master that. And at the end, they settled for a rather simple solution based on Memcache and MySQL. The MySQL, just one enormous table with I think just 4 columns where they kind of keep an ID and the type of the record and some serialized form next to it. So it's a very specialized use case they have, but still it works for them. Or to put it in the words of the architect there, he used an expression I really liked. He said, it is like Russian technology. It is simple, but it works. So we, of course, have the big hype around that, the competition, NoSQL. And I think there's a lot of very good use cases for it, but this is the rule you really should keep in mind with that, is that can really be great, but you really have to know what to use them for, and what the narrow field is where they really shine, and then they can be tremendous solutions. But I think the default should really be keeping things simple deployment topology, proven infrastructure, and so the relational database should really be your default there. Now, let's talk about database migrations. Our relational databases, of course, are something that carries a certain structure and that's been defined in advance, our schema, and that's then being used to store a bunch of data. So in this case here, we have a very simple screen here where we kind of enter a name and an email address, and then that maps onto some kind of table where we've got 2 columns for the name, for the email address, all nice and well. Until, of course, one day, this needs to evolve, and some new data needs to be recorded. In this case here, for example, an age column, and then it needs to land in the database. So how do we go about making this work? Let's see where we all stand. So who is today simply executing ad hoc statements on their system to make those kind of changes? Let's be honest. Come on, come on. Yes. All right. About 10 of you. Who is running ad hoc scripts where you've got a SQL script here, you copy it over, and then you run it on that system? All right. About the same number. A good quarter of you. Who works for a company that has written some automated in-house tool to solve this problem? Not some industry standard, but just a regular in-house tool just for you. All right, about 6 of you. And who's using a standard database migration tool today? That's good, about a quarter as well. And who's migrating their database on application startup? Very good, very good. Excellent. Just out of curiosity, who's using Flyway already today? Ah, perfect, perfect. I like that. So, if we have our application here, and we have our database there, actually not too bad. We could just execute a statement like this, and it would be fine, and we wouldn't have a big problem. That would add the column, done, actually quite nice. Of course, reality rarely looks like this. On most projects, it looks more like this, where every developer has one or more databases, maybe one for executing your automated tests that you wipe clean every time, and then another one for manual testing. And let's assume you have a team, for example, of 5 developers, so 5 times 2, that's 10 databases already. You add a CI server, you add a test server, you add a production server, that's 13 databases where this process needs to happen, where we need to add this column. So it is actually quite error-prone. It's actually quite easy to forget to add something there. So people started saying, okay, well, especially if we have more than one statement, why don't we just put them all in some file and automate it somewhere? And we'll create a SQL file with all our statements, and then we'll use some command line tool, like a SQL Plus in this case for Oracle, and just kind of execute all that. But that doesn't really solve all our problems, because how do I know if this still needs to be executed? How do I know if this script has already run or not? In what state is my database? In what version is it? How do I answer this question? And even if I'm able to answer it, immediately the next question arises. Over time, if I accumulate multiple SQL scripts, in which order should they be applied? How do I know which one should be run before another one? Because they do have an implicit order. They do have dependencies. I cannot rename a column before I've created a table that contains it. So I need to know in which order those need to be executed. So this is the exact problem space that Flyway tries to address. The credit where credit is due. I think the first guys that really came around with a comprehensive solution to this were the Rails guys, just about 10 years ago. They really, with Rails migrations, which is where the name migrations comes from as well, they really were the ones that came up with a good concept and popularized it and really made it work. So a lot of credit to them. But Flyway is addressing this in the JVM space and a bit broader as well these days. So it's not a new project. If you start with Flyway today, you're by no means an early adopter. It's been around for 5 years now, and last year there were 250,000 downloads. This number has already been crossed as of March this year. So I think we will probably hit 1 million this year. So it's been growing consistently for the last couple of years. And I think what that tells is it really tells two things. I think, first of all, people are starting to recognize that, yes, this is a real problem we have when we have a relational database. We need a good solution to that. Whether Flyway or some other tool is the right solution, I think that's secondary, but there needs to be a structured way to solve this problem. And the other thing I think this tells us is that as an industry, in general, we're kind of maturing. I think the open source offerings out there are getting really good and things that you can really start plugging in everywhere. So our friends at ThoughtWorks, they run their technology radar as well. Who's heard of the technology radar of ThoughtWorks? All right, not that many of you. So ThoughtWorks, they basically every 6 months, or they don't have a fixed schedule, but let's say about twice a year, they come out with this document where they present a list of tools, techniques, and ideas that they believe in or where they've had personal experience with and have been more or less satisfied with them. And so they've got different layers there, and the top one, which is basically their adopt layer where they highly recommend things, is where they place Flyway. And this is what they had to say. With techniques such as continuous delivery becoming more mainstream, automated database migrations are a baseline capability for many software teams. While there are many tools in this space, we continue to recommend Flyway for its low-friction approach. Flyway has a vibrant open-source community behind it and supports both traditional and cloud-based databases such as Amazon Redshift and Google Cloud SQL. So they're quite fond of it, which is good. And that kind of brings us to understand how Flyway works behind the scenes. How does it actually address these problems? And we've seen the problems, the question marks here we try to address. On the one hand, finding out in which version our database is, and on the other hand, in which order, which scripts should be executed. So these are really the two set of questions that the Flyway sets out to solve. And it does it in a different way. So they are solving the question of what's already been run on my database. That's being solved by adding an extra bookkeeping table in the database. By default, it's called schema_version, and that basically keeps track of every single script that's been run, so that it's then later easy to query, and you can easily find out if scripts have already been run up to version 5 or version 7 or whatever has been run there. So this table contains a bunch of information. It's a bit small here, but it doesn't matter. It contains the version of the script and description, the type, a checksum, which is also useful for accidental change detection, and when and by whom it was installed, how long it took, and whether it was successful or not. The successful flag is something I wish we wouldn't need, but unfortunately in 2015 we still have a large number of databases that do not support DDL transactions, so the data definition language, create table, and so on. You would think this would be standard by now, but unless you're using DB2, Postgres, or SQL Server, you're really out of luck. Oracle, MySQL, all these databases, even though you wrap all your statements properly in a transaction, if you have a DDL statement in there, they will still insist on sneaking in a commit before and after every DDL statement. So that really undoes all the advantages of the transaction. So that's why, even though we run all migration scripts within transactions, some of these may fail, and we can then not automatically roll it back, so we need to keep track of that. So if Flyway discovers, it has multiple ways to discover migrations. It can scan the file system. It can scan the class path if you're on the JVM. And it looks basically for files that fit a certain naming convention. And based on that naming convention, you can then know which version and which description you actually meant to give to that migration file. And now it finds out, like in this case, that we have a version 1 file, and so that version 1 file creates a bunch of things. So we saw the database empty. We have a version 1 file available there. If we execute a migration, it will be run and the objects will be created. And if a follow-up version comes along, let's say you have one directory where you keep your SQL files and you just drop in a new file in there, the next time Flyway runs and it discovers it's there, it will then look at the database, see that the database is at version 1. It has files for version 1 and version 2 available, so it will then migrate to version 2. And if you run it again, it'll say, okay, my database is at version 2. I've got files up to version 2. I'm all done. So, as I said, when I looked around in 2010 at the different solutions on the market for this problem there, I had this idea of what an ideal tool would look like, at least for me, and those really became the design goals for Flyway as well. I have a strong allergy, I'll be honest, to complexity. I hate things being overly complex. I think it's a siren song in our industry. I think we are naturally drawn to it, but I think it's a trend that must be really resisted, and that's why I wanted Flyway to just work. You plug it in, and it works. It's if you plug it into the API, it's one class, 6 methods, done. You do not need to wire a whole bunch of stuff together. It works the same across all clients. Everything's taken care of. We do the heavy lifting for you. So behind the scenes, there is more complexity, but that's hidden for you. So from an end-user perspective, it just works. And we keep things simple. I think this has been a very difficult thing to maintain over the years as people come up with many different types of requests for different features and solutions. It also means it's associated with a lot of disappointment of having to say no. Unfortunately, maybe not right now, maybe later or not, or it doesn't really fit to be able to keep it simple for the vast majority of the people. It's also strongly based on convention over configuration, so you don't need to write a boatload of configuration to get started. Almost everything that can be discovered automatically gets discovered automatically. You can always override these things as well with configuration if you want, but there are a lot of conventions everywhere. And also very important, no lock-in. I didn't want to have some kind of proprietary format for writing those migrations. I'm a big believer in using the right tool for the job, and if one day it doesn't fit the job anymore, you should be able to move to a more appropriate tool without a whole bunch of effort. And so in this case here, it meant using the regular syntax of your database, as simple or as complex as it may be. So Flyway's parser supports basically your native syntax, whether it's Oracle packages, stored procedures, delimiter changes in MySQL, all these things that are supported, so you can just take a dump you create with your native tool of your database and use that as your first migration to get started, and that'll just work. Another aspect, of course, is dependencies. Flyway comes out of the box with 0 required dependencies. If you use the command line tool, it even ships with the JDBC drivers, so you literally don't need anything to get started. It ships with a JVM, with a JDBC driver, and with examples for all the URLs, so it's very, very quick to get started. And as I said, just 6 commands. So we'll look at them in detail, but just a bit of an overview. So the first one's info. That's basically, what does the world look like? What do I have in the database? What do I have on disk or on my class path? How does it match together? What has already been executed? What's still pending? How do I know what these things are? The next one is migrate, which is actually evolving the database. If we find there is a delta between what we have available on the file system, for example, and in the database, we'll kind of start applying those scripts, and that's what migrate does. Clean is how shall I say? It's a very career-limiting command if you execute it in production. It is something that you can only do once, but in development, it's very useful. It's a way to basically take an existing schema and wipe it completely clean. So it will remove all objects in there, whether it's tables, views, but also user-defined types, or everything pretty much that lives within a schema gets removed there. If Flyway created the schema, it will drop the schema as well, but if it hasn't, it'll just work within the schema. And this is useful for organizations where you have a database that's basically being managed by some DBA, and your user that you're receiving doesn't have the rights to create and drop schemas, but you do have the rights to create and drop different objects within a schema. And so for that, it's very, very convenient, because it just, with one command, wipes it all clean. Validate is basically accidental change detection. It'll check that the scripts that you've run, the migrations that have been executed, are still have not changed in the meantime. It'll make sure that the checksum, that the names, that everything's still matching, so that the assumptions you've created of having your database at version 3 is actually still matching exactly the scripts that are used to create version 3, so that when version 4 comes along, you can deterministically migrate it. Baseline is something for existing projects, because the luxury of greenfield is something we rarely have. So in most places, you'll actually start with an existing project. And so baseline is just a way to tag an existing database that hasn't been been managed by Flyway before, as saying, this database is now at version 5, for example. Done. And so baseline will create an empty schema version table and add one row that says it's version 5. And repair is something that you'll rarely need, but it's useful if your database doesn't support DDL transactions and it fails somewhere in the middle of a migration. Then at least repair will not clean up the objects for you, but it'll clean up the mess within the schema version table. So it'll remove the row that has been marked as failed and just kind of takes care of those things for you. So let's have a look at it in practice. Yes?
Can we just clean the database scheme up to a baseline, not completely wipe out the entire scheme?
So the question is, is it possible to just clean a database schema partially up to a baseline instead of wiping it out completely? Yeah. This is not supported at this point. Flyway doesn't really know what you execute. It just basically does what you tell it to, but it doesn't really keep track of which tables you've created and all that. That's all kind of your responsibility. So no, it is not part of the features. So let's have a look at this in practice. So what I have here, it's a bit small, but it's okay. We'll make it bigger. Yep. I have first my migration file here. This is the naming convention that's being used by default. So you have some kind of prefix configurable, but the default is a capital V, followed by a version number. You can use a dotted notation there. And then 2 underscores, and then a description where you can either use spaces or single underscores. The single underscores will then get replaced by spaces, and a suffix, configurable as well. And then here, just include whatever statements you want to have in there. So I just have a simple statement here. And by default, if you integrate Flyway with the JVM as a library, it looks in a package called db.migration in your resources folder. It's a bit small here, but it doesn't really matter. So one way to run Flyway, and probably the most convenient way, is to use the command line tool. It's something you can download either zip or tar.gz files from the Flyway website, or if you're on Mac, there's homebrew support as well. And so what the Flyway command line tool has, I said, 0 dependencies, ships with JDBC drivers, ships with a JRE, so it's very, very convenient. And it supports the same commands we saw before. So in this case here, I executed a flyway.info, and it connected to a certain database. We'll see how it does that. And it basically found one migration, remember our file name, that had a version 1 in the description, and it's not been executed yet, so it's been marked as pending. How did Flyway find out where to connect to? We have a configuration file for that by default, it just looks in the current directory for the configuration file. It comes documented with a bunch of examples, as I said here, for all the JDBC URLs for the different databases, so it's easy. You just kind of need to drop in the placeholders. But in this case, what did we do? We added a URL for an H2 database and the username and a password. You don't need to fill in a driver class because this is something that we can detect automatically. Once again, we try to make it as easy as possible for you, so you don't need to remember the driver class for DB2 or for H2 or whatever you use there. It's just kind of based on the URL. We're able to use a sensible default. You can override it though if you want to use something different. So we've got our database here. We saw that that's not been executed yet. If we look at our database tools, here I've got it here as well. So my schema, refreshing, it's empty. We haven't got anything there. So if I issue a Flyway migrate, what I'll do is it'll scan the file system at the location we configured, and it found that it had one migration. It found that the database was empty. So it created a metadata table and applied the first migration, and that all ran successfully. So we've got it there. So if we just quickly issue a Flyway info, we'll see that we now have one migration applied successfully. And if we switch over to our database and refresh here, I'll expand it. It's a bit small, but just trust me, we have one table here called person, the one we created from our script, and the schema version table. So if we look inside the schema version table, make it a bit bigger here, we have the columns we saw where we saw the version here and our description, type SQL. This is something interesting as well because you actually have multiple types of migration. So for the vast majority of scenarios, you'll use SQL. But there are some cases where SQL as a language simply isn't the best solution. If you need to do a lot of complex data transformations, let's say normalizing phone numbers that have been in some random formats, it's quite complicated to do just with SQL, or if you need to deal with binary data, it doesn't work very well. So you have the possibility to write migrations in Java as well. What you need to do is just implement a simple interface with one method that gives you a connection, and the rest kind of works automatically from there. So we saw that we had our script here. That was the checksum, and it's been installed by the user SA right now, and it was successful. And of course, if we are in development, let's say it once more, we can do something like Flyway clean, which basically wipes our database clean. So it, in this case here, it just emptied the schema. So if I refresh here, it's all gone. It's now empty. And if I execute migrate again, it's it's all back. So that's a very, very convenient way to go back and forth. And of course, we can execute migrate one more time, and then it saw that it found one migration available locally. The schema is at version 1. Nothing left to do. So it's idempotent. It's always safe to execute it multiple times in a row. So that's very convenient, especially if you run it on application startup. So there are many databases supported these days. It's very likely that the relational database you're using is on this slide here. And you have many different ways to run Flyway as well. So you can run it out from the command line tool on whatever operating system you choose to use, but there is build tool integration as well with all the popular build tools on the JVM, and there is of course support to run it through the API either on Java or on Android, and that's of course not all. What you saw there were just the plugins and the functionality shipped out of the box. There are many third-party plugins. There's actually more than what's here as well, but for many frameworks, you have very good integrations that work there for you as well. So what is the architecture behind the scenes of Flyway? How is it structured? How is it working? So as I said, simple facade type of API where you kind of come in. So that's basically the Flyway class. And behind that, you have a bunch of components that work for you. So the first one is the migration resolver that lets you scan file system and the class path to discover migrations. Then, of course, they need to be executed. So that's actually the migration executor that does that, dividing them up in statements and making sure those statements are run correctly. Then there's the whole management of the metadata table and database-specific support, because our relational databases do tend to diverge a bit. So that's what we have there. But everything is using the API. So all clients are on equal footing, whether it's your own Java application or whether it's our Maven plugin that we ship, or the ant tasks, or the command line tool, or Gradle, or whatever other client there. It's all on equal footing. So everything we can do, you can do as well. And what does it look like from a code perspective if you integrate it? Simply like this. Just new up the class, pass in the URL, the user, the password, execute, migrate, done. Don't need to do anything else. If you execute it from Maven, this is what it looks like. Same configuration, URL, user, password. Same from Ant. Same from the command line tool. Same from Gradle, and so on. So that's all very, very easy there, and we can see how that translates if instead of using the command line tool, we would switch to Maven. So I could do an NVN Flyway info. There we go. Just need to clean the project. It's got some stuff in the target folder. And then we'll just run the command again. By default, it's looking for things in target folder. I think this is the default. Will change in the next release. It's a bit confusing, so we'll run it from the source folder instead. But there we go. So that's the exact same functionality. And if we look at the configuration in our pom.xml, this is what it looks like. So just increase a bit here. So this is the bit for our plugin, where we just define our group ID version, and then basically our configuration here. Everything's nicely documented. So you've got completion in IntelliJ, for example, and you've got documentation for all the things as well. So that's just a nice little thing there. So when should you migrate the database? Well, I actually strongly believe this question should be rephrased as, what is the life cycle of your database schema? And I find that the life cycle of the database schema is actually tightly coupled to the life cycle of your application. A certain version of an application has certain expectations of tables and columns to be present, so that you can then read and write to them from your Hibernate entities or whatever you choose to use. And in the next version, you may require a different set of tables and columns to be present. So they really share the same lifecycle. And if they really are this tightly coupled, why would you decouple them and risk having them not fit together at runtime? So I say that they really should be run on application startup. Just package all your database migrations with your application and execute Flyway programmatically on application startup. So, as we said, very easy interface, just 3 lines. That's all you need to include on startup in your main method, or on some servlet listener, or whatever you choose to use there. Just very simple, and that all just works for you. Important, you need to do this before whatever persistent tool you're using starts up. So if you're in the Spring world, this would be a bean, for example, with XML configuration, where you have some kind of depends on relationship, where Flyway needs to run first, so that you can then ensure that by the time a tool like Hibernate starts, the schema is already in the state that Hibernate will expect. Yes, of course, there is integration for frameworks there. So Spring Boot has, for example, awesome out-of-the-box support for it. Makes it very, very easy. So that works great there. So one of the things I want to talk about as well is this widespread industry fallacy. It's what I like to call the fear of DDL, where if you look around you, many people will actually have this mental model where data manipulation language is this little innocent thing, and that's fine. And as soon as you kind of start changing the structure of the schema, then woo, that's dangerous. There you need to watch out because you're really in for some trouble. And that's usually the case. The reason why you can ship 10,000 lines of new code into production and nobody cares, and as soon as you ship 3 lines of SQL, the DBA is there, and it's kind of a big fuss. And so I think it is time to really dispel this myth, because nothing could be further from the truth. If we look at a simple example here, we've got our simple table with 2 columns, the name and the balance of some accounts table. And we execute an update statement, but unfortunately, we make a mistake in our where clause. So this is what we get. We basically, it doesn't matter whether the number on the right is a 0 or 666. It doesn't matter. The minute you have the power to change data, you have the power to destroy it. And so whether this happened on the left or you accidentally dropped the column, as here on the right, it doesn't matter. From a business perspective, the risk is the same. Either you have a very good backup or you can close shop. So the minute you have the power to change data, you have the power to destroy it. Remember that. The risk is exactly the same from a business perspective. So it is not a big deal to include something like Flyway and to have the necessary rights for that user on application startup. So let's quickly switch back to our little demo project here. So I've got a very simple class here that just kind of runs. Flyway connects with the same database. So if we just run this little demo here, we see what happens. So it starts, and then we have our basically found one migration, and it sounds that it's up to date, and that's working fine. So suppose that over time we need a further evolution of the schema. We write new migration files. All we need to do, we don't need to change anything in the configuration. We just drop these files in the folder we've configured. So by default, db/migration on the class part. So I've added 2 more files there, and I can just run my little demo again. And what it found here is basically it scanned it again, the second run. And it found, okay, my database is at version 1. I now have a new migration to version 1.1 and one to version 2. So I'll run both, and then I've successfully applied them. So if we do a quick Flyway info, we'll see that they've now all been run successfully. So it's really something you set it up once, and then you can pretty much forget about it. All you need to do is drop further migrations in that one folder, and it'll just run automatically for you. The next time the application starts, it'll get migrated, and that'll be it. And if it's already up to date, nothing will happen, and it'll just start up normally. So I want to briefly talk about in-memory databases as well, because this is something that often comes up where on projects you'll have a real database on some server somewhere, and for development, for efficiency purposes, you'll have some in-memory database on your local machine. And I think this is something you should carefully think about, because every difference you introduce between your environments is a potential source of trouble. And this is certainly the case here as well, where the syntax and the capabilities of in-memory databases slightly differ from those of the real databases. Even though they do have compatibility modes for the syntax and so on, it's still slightly different. For example, H2 allows you to execute multiple statements within one statement.execute. JDBC call doesn't work on Oracle, for example. So these are surprises that you then discover late in the game. And so in the world where we live today, where development machines have 8 or 16 gigabytes of RAM, and we have enough multi-core CPU power in there, I think you should really think twice about this, and maybe an Express edition or something closer to your real production environment would alleviate some potential causes of failures there. So just something I want to leave you with to think about. Now, if you want to get started with Flyway, if you want to go back to your projects next week and get started with it, we actually have a whole bunch of guides available at flywaydb.org/get started. And then depending on the way you want to use Flyway, you can then use the appropriate guide there for the tool you want. So either via the command line or the API or Ant, Maven, Gradle, SBT, whatever you want to use. And they're all written in such a way that it's a 5-minute to success type of guide. So you literally need just 5 minutes from the beginning to having it actually set up and working for you. So that's a great place to get started. So if we're going to summarize this, I think the main point is actually that you should use a database migration tool to solve this problem. We saw how many databases you have that must be kept in sync, even on simple projects. It's very error-prone to do it manually. So use a database tool to do this. On the Flyway homepage, there is a comparison matrix of the different tools available in the JVM space. Just pick the simplest one that works for you. I don't want to influence your decision as to which one this should be. But I do have some opinions, I must admit. So if you're thinking about when to run it, try to run it on application startup, just because you avoid the risk of discrepancies of things not fitting together at runtime. It's just one less cause of failure. So that's always good if you can do that. And then only if that's not an option, move to the other types of running it. If you're in a continuous deployment type of environment, you do need to put a bit more thought in your migrations if you want to do it with zero downtime. So in that case, there you need to write them in a backward compatible way as well. So once again, here's the Flyway homepage. If you want to check it out, and that's all I had for today. So thank you very much. We have a few minutes for questions, so if there are any questions, shoot away. Yes?
I have one. In an environment where you're sort of branching code, so for instance, I've got version 1 on production, I've got version 2 on the QA environment, I need to patch the production version 1. I'm likely to put in another database migration in that sort of point further back in history. Is there any advice for whether Flyway will be able to handle that?
So the question is, in an environment with branching, where your production may be at version 1 and your QA environment may be at version 2, and you need to apply some fix to production that involves a database change, how do you deal with this? Can Flyway help you there? So the first thing to remember, of course, is that from a database perspective, all the changes will be linear. So if you've already applied version 2 on your QA environment and a version 1.1 comes along, it'll get applied after it, so it may change some things. So by default, Flyway will reject this, but you do have the option to override this behavior by setting an out-of-order flag to true that will allow you to apply a 1.1 after a 2.0 has already been applied, with the risk, of course, that if you were to recreate it from scratch, you may get a different result. But so that's possible there. And then for the naming scheme, that you have to figure out a way that works for you, whether you're using a dotted notation or inverted timestamps or whatever you want to use to kind of guarantee the right ordering there. Yes? So how would you use a Flyway when you have multiple database targets? If you have Oracle here and maybe SQL Server there, you have different options to do it. As always, start with the simplest thing possible. So if your DDL runs on both databases, fantastic. You don't need to do anything. But if that's not the case, the next thing you can do is work with Flyway's placeholder support. If you have tiny differences, if you have little clauses that change in certain places, you can replace those placeholders. Or if you reach the limitations of that, you do have the option to load migrations from not just one, but from multiple sources or locations, as they're called in Flyway speak. So you can configure a common one for all your databases, and then if you have a migration that's really different, then you can have a version 4 for SQL Server and a version 4 for Oracle, and based on the current environment and your configuration, you would then load either the common one plus the Oracle-specific ones or the common one plus the SQL Server ones. But that's how that goes there. If you really find that you're doing this all the time and have bigger problems there, then maybe Flyway is not the ideal tool for you. Maybe tools that do support an abstraction over that, like Liquibase, may be better choices. I think that's the guiding line there should be use the simplest tool that works for you and start simple and evolve from there. Any more questions? Yes.
When you have a really, really large database, when migration takes like days, and you need to first deploy to like staging environment like QA, where the migration is like this because you don't have enough data. Do you have any suggestion of how to go about it? Because when you deploy to staging, you want to run it like on startup when you deploy the application, but you don't want to do it on production.
So how do you deal with really large migrations or migrations that take a very long time to execute? And how does that relate to executing it on startup? I think those type of migrations bring the special types of challenges. Flyway doesn't offer you any magic out of the box, but you have a number of techniques you can use. Depending on how much locking is also happening during the execution as well. You can look at doing it. You could do it on startup if it's backwards compatible and it doesn't lock or doesn't prevent the current version of the code from running and serving your users. Then I'll just run a long time in the background. That's okay before it starts. But if that's not an option, you can do something like building a read-only mode in your application to kind of switch it to that and then migrate the replica and then switch it afterwards. Or database-specific solutions like MySQL has with atomic renames of tables and so on. Okay, so we're out of time. I'll still be around for more questions. I have some Flyway stickers here as well if you want to pimp your laptops. Otherwise, thank you very much.